All right, we got one last section in 5.5 or chapter 5. This is 5.5 and it's on counting techniques. That break rejuvenated me, even though we fucking spent like 20 minutes. It was worth it.
We deserved it.
We deserved it. It refreshed us and made it so that we can go the rest of the whole 2.5 hours more. Those in the back could not see my eye roll. All right, so like a typical California license plate. Comes in the form of a number and then 3 letters and then 3 numbers. This is your default setting on a license plate. How many different combinations are possible? I missed the word R. And that is the worst S ever. It's like a $S. How about we just fucking rewrite that part right there? How many different combinations are possible? So, how many different choices do we have for the first character?
Wait, 4.
It can be any number.
Oh,
Nine.
Plus
10.
Oh, yeah, because there's 0.
10. So numbers can be any of 10 different digits, 0 through 9. Let's address the letter thing while before we let Mateo tell me fucking 8 or some shit like that. How many different letters are in the American alphabet?
21.
26.
Now you're just trolling. Don't troll me, boy. A to Z. So like, we could have 0 A 0 0 0. We could have 0 B A 0 0 0. And so on and so forth. Like we do a lot. So the way it ends up working, this is just like the dice. Each character does not affect the next character. So we're multiplying, but we're not doing probabilities. We're not doing like 1/6 times 1/6. We're doing that like how many different options we can multiply. So this is going to be the first character can be a number, and there's 10 different options. And the second character can be any character or letter, so 26. And you can have repeat letters, so it's going to be 26 each time. And then when you get back to the numbers, it's 10 again. This means there are 175,760,000 plates, license plates of that form in California. Or can be up to that many, I should say. We don't have that many residents, which is a good thing. Yeah, we'll get there. So what's the probability of having any specific plate? If we're just looking at those combinations.
1 out of.
Probability of specific plate would be 1 out of that, right? And I don't feel like throwing it into a calculator, so if you want to know, go knock yourself out. What if I don't want any repeats? Is there any restrictions on the first number? No, first number's fine. What about the first letter? First letter's okay too. What about the second letter? If we already picked x, we can't use x again, so there's 26 minus 1 is 25. And let's say the next one is y, we pick y. Now for the third letter, we can't use x or y. There's only 24 left. You'll notice that as we use one more of an item, the number just keeps decreasing. That's going to happen when we go back to numbers. There was 10, but let's say we use the 8. We can't use the 8 anymore. There's only 9 options there. And you'll see this goes down for the remaining 2, and we'll have that to multiply. And that is 28,624,000, which is still a lot of plates, but a lot less. So these are the multiplication rules of counting. This top one, really what we're going with, is the multiplication rule of counting. If we had some dinner menu, this happens like if you go on a cruise, you have limited selections when you go to a sit down dinner on a cruise. They'll give you like P different appetizers to choose from, Q different entrees, and I think we put a little dash over the E because we're fucking fancy. And it's not the same without dessert. And if we do the number of combinations, we have P times Q times R combinations. You guys ready for some more? John Luke is over here on the very fucking edge of this page. He's like trying to fill in this fucking like this strip right here. John Luke is over here like, I'm not wasting any goddamn paper. I can get some text right there. It's even worse than Mateo. Mateo just writes small, but he doesn't like I'm gonna use the edge of the fucking paper.
I do some.
Some. You guys ready for more? I'm waiting to see your pencil stop moving. So I should just ask you, if you're doodling when you're doing it, let me know I'm just doodling right now, okay? Because usually I'm waiting on you, which is fun. I'm not trying to rush you. I want to make that crystal clear. I'm not trying to rush you, but if you are doodling, I will go on. You need to take as long as you need, and we are good with that. All these other motherfuckers, they can wait. All right, so in case you guys don't know what factorials are, let's talk about factorials because we're going to use them. Most calculators have a button like it. Mine is right above that. Let's see where I can get it to show up. It's right there. It's that X with an exclamation point. So this is a button on my calculator. If your calculator doesn't have it, your calculator might have a button called PRB for probability. And generally when you do it, it'll give you 3 choices to choose from. It will say N factorial, NCR, and NPR. So the factorial, that is the symbol for a factorial. I think rather than trying to put it in words, I'm just gonna show you a fucking factorial. And you'll be like, okay, I get it. I don't need words. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times what?
I don't even know how you would put that in words. Like
You
if I'm
start with the number of the factorial and you multiply it by you
decreasing.
keep decreasing by 1 until you get to 1. I don't think you need to once you've shown it.
Yeah,
We're cool, right? Like 20 factorial is a bitch to write out, okay? There is a way to shorthand this a little bit, and we'll take advantage of that some. Like, I could write this as 7 times 6 times 5 times 4 factorial. Because 4 factorial is 4 times 3 times 2 times 1. So keep that in mind, because we're gonna take advantage of that, because I don't like using a calculator as often as possible. I avoid it as much as possible. So like some math, you don't need to fucking do this. It's easy. You don't need no fucking calculator. We're champions in here. We're college students. We're out here to get an education. All right, so where we use this in the rest of this section, we're looking at permutations versus combinations. This is NPR. This is NCR, with the middle letter generally being larger than the other letters. I don't have a probability button, but I have NCR right here. And you can't see it, but NPR is right above it. So the way these work, we'll do combinations first. But for both of them, N means N distinct objects. So unique objects. How many unique objects do we have? If we're going by people in this room, right now there's 9. Even if you all had the same fucking name, it was all David, it would be glorious. We'd still all be unique people. I don't get a lot of Davids in my class, I really don't. I think I talked to you guys about that the other day. R is going to be the number of objects that are selected. And that's true for both. Maybe the NPR is easier one to go first. But let's talk about what the difference is. Combinations. Think of combination pizza. Easiest way to remember this. Combination pizza. Do the order that I put the toppings on matter?
No.
Mateo was quick with that. No. The only topping that matters first is the sauce. You don't put that sauce on there first if shit's going downhill. But no, we don't call that a topping. So for combinations, order doesn't matter. Another example is if I said, I'm going to pick two of you, you're automatically gonna, well, I'm gonna randomly pick two of you, make it fair, right? I'm randomly gonna pick two of you to get an A+ in this class, and you don't need to take the midterm or the final. Do you give a fuck if you're the first person selected or the second person selected? Not really, so long as you're selected. I hope you don't want a free A+. I hope you want to earn the A+. Like anything given to you is like that just feels dirty. It's not merited, you won't appreciate it. Like the car that your parents gave you when you were a kid, you trash that motherfucker. I didn't get a car as a kid, I don't know.
I got my ass.
All right, permutations, order does matter. First, second, third place, baby. You don't want to be third place. You don't want to be second place. What's another name for second place?
First place.
First loser.
Me first to last.
What?
Me first to last.
Right? First loser. You're not good enough. The only time second place is okay, it's still not good. Because you lost when you're fucking playing Monopoly. With more than two people. This is why Monopoly is the worst game on the fucking planet, because it's supposed to be a fucking family game. But when one person's out, they ain't sitting around watching everybody else play for hours. Like they leave. So it's like, how much of a family game is it? You keep losing people that have to go do something else until someone wins. It's a fucking terrible game. When you go to like the first person to get so many points, that's a good version because everyone's playing the whole way. Let's take a look at this here. First, second, third place, or like, think of it like maybe we're picking people like for a club and we need the president, we need the vice president. We're gonna pick like the secretary and the treasurer. We're gonna pick people for the club. Order kind of matters because if you've been picked for president, you can't be picked for vice president, and I would rather be president than vice president. I don't know. That depends on your priority. You may not want to be the person in charge. You maybe want to be the treasurer so you can embezzle that shit. Don't do that. That's a terrible thing. The only form of stealing that's like universally accepted is stealing fucking office supplies from your work. You need some paper clips at home, you take some fucking paper clips home. You need a thing of post-it notes home, you take a thing of post-it notes home. No one, even if your boss sees you doing it, they might tell you to put it back, but they're not gonna get you in trouble. They're not gonna write you up. This was a stupid tangent. Let's get back to this right here. Okay, so what is the formula for NPR? We went over factorials, so guess what's in it? Factorials. NPR is n factorial over n minus r parentheses factorial. I'm going to tell you a story to show how it applies. When I was like 12 or 13, I grew up in Sacramento. The state fair is in Sacramento. One of my best friends, he's no longer my best friend now, but he's still a good friend. His father-in-law fed the horses at Cal Expo where the state fair was held. So we'd always get into the state fair for free. He'd go to the back gate and they go, yeah, it's Kenny's kids. And so they let us in. And so it didn't matter who we took, because sometimes we would take family members. So my mom gives my cousin Annette $20 for me and my brother Brian to go do some stuff. And we go in through the horses. And so she decides she's gonna take it upon herself to show us how gambling on horse races is bad. So she introduces us to the trifecta. The trifecta in a horse race is you have to pick first, second, and third place horses. It's hard enough picking who the first place horse is going to be, let alone picking the second and the third. They're like $2 tickets. Well, they were like $2 tickets at the time. I don't know what they are now. What she didn't know, no, she knew this. She knew we didn't know a goddamn thing about horses. What she didn't know is that I had a knack. I saw some names. I don't remember what the horses' names were, but I liked their fucking names. I said, I like that horse's name the best. I like this horse's name next. And I like that horse's name third. So that was my trifecta ticket. She spent $2 of each of our $20. This is like 35 years ago. So it's like $20 goes a lot further than it does today. I fucking nailed the trifecta. I don't remember how much money it was. That bitch didn't let me spend any of it at the fucking state fair. There's fucking rides to go on. There's all sorts of shit I could have spent money on. That wasn't the lesson though. The lesson was gambling, you lose money. So she went home and she gave that money to my mom afterwards. And I don't remember what my mom said. I know she liked the money. I don't think she heard my plea when I said that was my money. I don't think she gave it to me to let me spend it, but I don't recall. I wonder if my brother remembers. I'll have to ask him. My mom passed away last September, August, so I can't ask her anymore. But my brother might remember. But let's say there's 12 horses. How many different horses can take first place? First place, it could be any of the 12, right? After that, how many can be in second place? 11. And third place is 10, right? So without using the formula, the number of tickets or number of trifecta outcomes is, we're going to use a multiplication rule of counting. 12 times 11 times 10 is 1,320. Now let's take a look at NPR. N is the number of different unique objects. There are 12 horses. So here, N equals 12. And we had to choose 3 horses. R equals 3. So NPR will be written as 12P3. It equals n factorial, which is 12 factorial, over 12 minus 3, n minus r factorial. So I have 12 factorial over 9 factorial. But if I write out 12 factorial like this, 12 times 11 times 10 times 9 factorial, and I have 9 factorial on bottom. This is why I did the 7 and the 4 earlier, to show you how simple this gets. I have the same thing on top and bottom. The 9 factorials go away. And I am left with 12 times 11 times 10 which I actually multiplied in my head. I didn't grab a calculator. And, oh, I do have the amount written down in my notes, but I didn't look. Because I know how to do multiplication times 11 and then times 10. I can do this in a calculator a couple ways. I can do 12. You can't see my shit, so I gotta move that. 12, and then I can do the factorial. I don't even know, I don't want to hit equals. I think that's gonna blow it up. No, it doesn't blow it up. I can do 12 factorial divided by 9 factorial. And it goes straight to it. The 1,320 that we got up here. Or I can use the NPR button. For me, I gotta use the shift command to get to the one above NCR. So I'm gonna go shift 12, shift, and hit that to get to the NPR, and it gives me a P. And then I say 3, and it gives me the same 1,320. So it does the factorial work for you. If you have your calculator with you, try to get 1320 right now. That way you know how your calculator works. Because like if you don't know how to do it, maybe I can help you figure it out. It'll speed up doing homework and shit.
Yeah, do they do that on the phone calculator too?
Like, would you recommend buying a calculator like this?
Some phone calculators do it just fine. It just depends on what yours has. Now, did you need one that does it? You don't, as long as you do a little bit of math work first. You really only need a multiplication button. But it does speed it up. And you don't have to remember the formula if it has an NPR, NCR. If it doesn't, you just have to, if it's got a factorial button only, you gotta do that one. If you have the PRB button on your calculator, did anyone not find it on their calculator?
You just do it manually.
You can do it manually, that takes a while though. If you're gonna do it manually, try to cancel shit out like I did here, okay? If you're gonna do it, otherwise it's gonna take you a while to type that shit in, and you're gonna be done with it before you do like 7 numbers. You're like, nope, this is done. There's gotta be a better way. So there's 1,320 ways for those horses to place first, second, and third. So what's the probability of winning the trifecta? I bought one ticket, and there was 1,320 different ways that it could have been done. This is 0.00758, which is 0.78%. I had less than a 1% chance of picking the trifecta. I didn't move the zeros enough. I'm like, that doesn't seem right. There's another 0 in there. So 0.078% chance. That needs another 0. I wonder how many times I've taught this fucking lesson and put up the wrong value at the end. Like my notes had it with it, and I'm like, that doesn't seem like the right percent. That's almost 1%. 1% is 1 out of 100. This is 1 out of 1,300. There's no way it's almost 1%. That's combinations, or that's permutations. When we look at combinations, NCR, it's n factorial over n minus r factorial times r factorial. This one, when they read NCR, they don't say NCR. This is read as N choose R. So if you hear that being said in like a presentation, or 13 choose 4, some shit like that, if they're saying two numbers with choose between, they're talking about this combination thing. My example with 2 of you get A pluses, how does that work here? 2 free A pluses. Let's look at the math. If we do, there's 8 of you, and we're gonna do combinations 2. This will be 8 factorial over 8 minus 2 factorial times 2 factorial. So I'm going to do this. 8 factorial is 8 times 7 times 6, and I'm going to stop there because I know 8 minus 2 factorial is 6 factorial. And 2 factorial, I'll write as 2 times 1. The 6 factorials cross off. And I can simplify the 8 and the 2, right? 8 divided by 2 is 4. I have 4 times 7 is 28. There are 28 ways to pick 2 students out of 8 if order doesn't matter. So if I were to do this, you have a 1 in 28 chance of being selected.
And R is the sample.
R is the number of objects chosen. So in this case, I was picking 2 people. N is the number of people in the sample. And there's 8 of you. You guys ready for a little bit more? Let's say there is a lotto. I don't want to pick the actual numbers in the lotto because I might give you this as a problem on one of your tests one of these days. No, it's not going to be on your final because those are all. It's a fun question though. It might be in the midterm. I don't know. So let's look at like lottery options. Let's say there are 75 balls and 6 balls are drawn. So we want to know how many ways, how many different ticket combinations are there? Because most lottery things, they don't care if it's the first ball or the last ball, as long as it's one of the balls. The only lottery option that matters like that is like the mega ones, where the mega has its own thing. And then that's specific, and you do it a little bit different. So we're doing, since the order doesn't matter, we're going to do combinations, and this is NCR. N is the 75, that's the total number of balls available. R is the 6. There are ways of cleaning this down by hand if you don't have a calculator with even a factorial button. And we'll explore them real quick. 75 minus 6 is 69. So if I do this, I have to go 75 times 74 times 73 times 72 times 71 times 70 times 69 factorial. And I have 69 factorial there. I'm gonna write out the 6 factorial because that's where I would start wanting to cancel shit. We'll do this the quick version in a second on the calculator. But this is doable even without a calculator, even by hand, as long as you remember the formula. The 69 factorials go away, right?
Yes.
75 is 5 times 15. So I can cross off this 5 and this 5. In fact, 15 is 5 times 3, so I can cross off the 3 as well using this. $72 is 6 times 12, so I can cross off the 6. $12 is 4 times 3, that's where I was thinking next. 4's go away. And I can divide 2 into any of the even numbers. 70 is an even number. I can do the 70 to the 2 and have 35. What I have left is 74 times 73. I got the 5 in the front, don't forget that. The 72 has a 3 left. I have 71 and 35. Let's see what that value is. 5 times 74 times 73 times 3 times 71 times 35. I'm getting 201,359,550 by doing this canceling method. Now let's do 75, choose 6 in the calculator. 75, choose 6. So doing it in the calculator, it speeds it up. And you get it either way. Let's go back to our 18 boys, 12 girls. Or 18 girls, 12 boys? 18 girls, right?
Yeah.
And we want at least 1 girl out of 4. I figured how to set it up with this. This is, I me think about it for a second. We'll come back to that on Monday if I think of it. Let's do another problem. It's not as simple as just plugging it in. It's a little crappier. Well, is it? It's not. Let's do it. Let's do it. 18 girls, 12 boys. And we're doing that 1 minus the probability of getting all boys. So the way we gotta figure out that out is this is the number of combinations of all boys. Combo of all boys divided by total combinations. So it's 1 minus choosing all boys should be, there's 12 boys, how many different ways can I pick 4 boys out of the 12? There is 12 choose 4 boys combinations. Out of 30 choose 4 total combinations. And this is where this is without replacement. So it's gonna be a different thing than we did last time. But this is like, if I pick Johnny, we're not picking Johnny again. That kind of thing. So like, if we were to do it the long way, there are 12 boys, like the first option we would have is 12 boys out of 30. And then it would be 11 boys out of 29. And then there's 10 boys left out of 28. And then there's 9 boys left out of 27. That would be doing it the long way. Let's see if that matches up with 12 choose 4 over 30 choose 4. Twelve choose 4 is 12 factorial something's off. This isn't gonna work. This is NPR. Because order matters. Order matters here. Fuck, it's not NCR, it's NPR. These are P's. Order matters. I said we can't pick the same boy. NPR is 12 factorial over 4 factorial. If I multiply this out, it's 12, 11, 10. I don't want to do all that. I'm going to just leave it as 12 factorial. 30p4 is 30 factorial over 4 factorial. What am I fucking doing? It is not. I'm just fucking tanking it today. Let's try this again. 12p4 is 12 factorial over 12 minus 4 factorial over 8 factorial. There we go. I need the parentheses
So
there.
you don't need the extra 4 factorial?
No, because we're not doing the combination, we're doing the permutation. This is 12 times 11 times 10 times 9 times 8 factorial over 8 factorial. So the 8 factorials go away. And so the 12p4 is 12 times 11 times 10 times 9. If we do the 30p4, it's 30 factorial over 30 minus 4 is 26, 26 factorial. So this will be 30 times 29 times 28 times 27 times 26 factorial. And the 26 factorials cancel out. And you can see that if I do the 1 minus 12p4 over 30p4, now that I got my head out of my ass, the 12p4 is 12 times 11 times 10 times 9. And the 30p4 is 30 times 29 times 28 times 27. And that's the same thing I got right there. So, for a problem like that with the at least one thing, I don't think using the permutations is the way to go. Because there's a lot of shit to remember right there. Reasoning it out and going, how many boys can I choose from for the first boy? There's 12 out of 30. And then going, I need the next one to be a boy also. I've only got 11 boys left and there's 29 kids left. And doing that route with the decreasing numbers is the way to go for doing a problem like that. But you can do it with the NPR. That was lame. Fucking stumbled over that one like a dumb shit. Maybe I should write down my notes. I wrote do NPR. It's not as intuitive as it feels. You gotta think about it for a while. You'll have that same problem when you're doing shit too. If you can, always think, is there an easier way? This top one is the easier way. We have one topic left. Okay, almost done. It's like a third of a page on my notes. So if you need a ride, text your ride real quick and say, come get me. Jones is gonna be done in 10 minutes. That's you, Brenda. I don't know if she needs to write today. She got to write yesterday. All good? I didn't even write out what the amount is. Does the amount matter? This is a calculator.
It was 11,880 over 65,000, or 657,720. You take that and you subtract that from 1, it was 0.9819 chance of, or
So 0.982?
yeah, of getting at least one girl.
Okay.
Different than what we got last time we did it.
But last time when we were replacing the girls,
9-7.
we were replacing the person we drew at each time. Here we weren't. So that was 0.982, if you want to know.
I got totally different here. Oh, no, man.
This is subtracting it from 1 after.
Yeah, you gotta figure out what it is.
It was 0.
What was the fraction again?
11,880 over 657,720,
I forgot to subtract by 1.
which is 0.0181. And then
This is 0.181.
0.0181. 0.0181. And then subtract that from 1, and you get the 98.
All right, now your notes are complete. So, that's better than what I wrote. Maybe I need to change my shit in my, all I got in my thing, I have listed 1797 over 1827. So I must have done some fraction work before I fucking did all that. It must simplify. Clearly it simplifies. We could divide out of 0, this fraction gets smaller. They're both divisible by 20. That makes it a little bit smaller. Either way, now that she's texted and said, I'll be ready in 10 minutes and we wasted another 5 minutes. Now let's talk about non-distinct objects.
It is still in 5.5.
Yeah. We've been doing NPR and NCR required distinct objects where we could see the difference between the horses or the people.
Options or objects.
Fine. Be picky.
I feel bad about it, but I know if I go back and I see that you wrote options.
I'm glad you said it. I'm fucking around. So let's say we've got 5 white flags. That's a 5, not an S. 5 white flags. You know what? Fuck it. They're gonna be green flags. I've got a green pin. Let's use green. 5 green flags, 3 blue flags, and 2 red flags. How many different orders can I put this in? It's unlikely you're going to memorize the formula. So I'll show you a way of reasoning it out. So how many flags is it? That's 10 flags, right? 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to put in 10 flags. Let's start with the green flags. I can put the green flags wherever I want. So let's say I put a green one there, and I put a green one there, and I got a green one here, and I put a green one there, and fuck it, we'll do another green one right next to that one. I got to choose where I put them, and it didn't matter what order I put them in. This is like an NCR thing. The green flags were, I had 10 choices to put them in, and I needed to choose 5. So if you write that out, we're not going to clean up the factorials. I'm just going to leave them as the 2 factorials. This is 10 factorial over 5 factorial, 5 factorial. The next option were my blue flags. I had 3 flags. And I could pick where they went. Blue is my favorite color, so I'm going to put it in front. Now let's say we had a blue there and a blue there. There was a total of 1, 2, 3, 4, 5 spots I could put them, and I got to choose where to put 3 of them. Blue flags were 5, choose 3. So this is 5 factorial over 2 factorial, 3 factorial. The red flags, I didn't get a choice. If you want to see what, when you don't have a choice is, this is 2, choose 2. Which is 2 factorial over 2 minus 2 factorial times 2 factorial. That is the fucking one thing I didn't explain earlier. God damn it, I didn't explain 0 factorial. It's important to know 0 factorial is defined to equal 1. 0 factorial equals 1. So you'll see that this ends up being 2 factorial over 2 factorial. There's only one option, but I'm not going to do that because I want to show what the overall outcome is. Leaving the 2 factorial in helps. I want to show you where the formula comes from. So if I take these and multiply these together, because that's how we do when we have different objects, I have 10 factorial over 5 factorial, 5 factorial. And then I have times 5 factorial over 2 factorial, 3 factorial. And then I have 2 factorial over 0 factorial, 2 factorial. Let's start crossing stuff off and see what remains. I can cross off this 5 factorial and that 5 factorial, right? So we'll cross those two off. And I got a 2 factorial here and a 2 factorial there. I can cross those off. And 0 factorial is just 1.
Can you take off the 2 and the 5 factorial for the 10?
No. Because remember, we multiplied out, it'll be 5, 4, 3, 2, 1. But the 10 is 10, 9, 8, 7, 6. We don't want to cancel, but I don't want to, if we wanted to calculate it, we could. We can work everything out. But I think showing where the general formula comes up from is what I want to do first. This simplified to 10 factorial over 5 factorial, 3 factorial times 2 factorial. Do you think that's coincidence?
No.
No. This is total options, or total count, factorial on top, flag A factorial, flag B factorial, flag C factorial. And there's a general form for this. If you have n objects with k groups of like repeating objects or the same object, they describe this as n factorial over group 1 factorial, group 2 factorial, dot, 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 times group k factorial. So here we had k was 3 different groups of the same object. I don't think there's a problem on the midterm like that. I'll double check. I'm sure pretty sure there's a problem in the homework that has it, just so you can see it. That's it. That's all I got. You are free to get the fuck out if you want. You can stick around and ask, does anyone have any questions? All right, you can, if you wanna do homework, work on homework here, you can. If you don't, you can go home, you can do whatever you want, you can do fucking push-ups, go play baseball. Whatever gets you through your day. I will see you guys on Monday.